everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over systems specifically by substitution, and we're going to elevate these problems a little bit where we're going to have to put our y or x alone, and there's going to be fractions in either both the variable term and the constant, and then we'll substitute in. So these are a little bit more of challenge questions that you'll possibly see in your class, so I wanted to make sure we are going over these. So as always, we need to look at the steps. So for the steps of a systems problem, we want to solve one of the equations for one of the variables. So this could either be the x or the y. I know we're used to putting it into slope-intercept form. We're getting the y by itself, but we can also get the x by itself. Once we get that equation with the variable isolated, it by itself, you're going to plug it into the other equation. Don't plug it into the equation you just manipulated it. Put it into the other equation, and then you're going to solve for that variable. So there's going to be one variable now. You're going to solve for it. Once you solve for it, you're going to take that answer, plug it into one of the original problems, and solve for the other variable. We'll then get an ordered pair point, and that's our solution. We have our x, we have our y, that's going to be our solution to the systems. That's where those two lines intersect. So let's take a look at the first problem. So first we have negative 6x minus 4y equals negative 6, and 6x plus 5y equals 9. We want to see where they intersect, and we're going to be using substitution. So I like to look at my problems to see if any of the numbers are similar, divisible. So we have a 6 and a 9. Those don't evenly go into each other. 5 and a 9, those don't as well. I have a negative 4 and a negative 6. Those don't go into each other evenly using a integer, but negative 6 and negative 6 will. So that will help me be able to have at least one of my components of the equation not be a fraction. So let's solve for x. So I'm going to have a constant that's going to be an integer and not have to deal with as many fractions as it may happen. So I'm going to solve for x. So I have negative 6x. To get the x by itself, I have to add the 4y over. So I'm going to get equals 4y minus 6. We use our inverse operations where if it's a negative, we have to add it over to the other side. Now I need to get the x by itself. I can't do anything until that x term is alone. So I'm going to divide by negative 6, and I get x equals, I get 4 divided by negative 6. We want simplify. We want the simplest fraction. So I am going to get negative 2/3 y, and negative 6 divided by negative 6 is 1. So that's going to be what my x equals. That was from my first equation, so I'm not going to plug it into my first equation. That's not going to help me. I'm going to plug it into this one. So instead of x, I'm going to put this here. We're substituting it in. They're the same. So I'm going to put 6 parentheses negative 2/3 y plus 1 plus our 5y equals 9. And now we have the same variable. We don't have two variables anymore. We're able to solve this equation. So I like to do 6 times negative 2 is negative 12. Divided by 3 is negative 4y. Plus 6 plus 5y equals 9. Then I need to combine my like terms. So negative 4y and 5y give me y. Plus 6 equals 9. Subtract the 6, I get y equals 3. So my y is 3, but I'm not just asking for the y, I need my x as well. So I could plug it into either one of these equations. I'm going to choose the second one. I just would rather work with something that has the positive values, the coefficients. So I'm going to plug it in here. I get 6x plus 5. We found my y is 3, so plug it in. Equals 9. So we get 6x plus 15 equals 9. So 6x equals negative 6. Subtract 15 over, I get negative 6. So my x is negative 1. Now I have my x and y. This is not 100% done though. I need to put this into an ordered pair or I'm not 100% finished. So my final answer is going to be negative 1 comma 3. So at first this problem might seem a little bit scary. I have fractions involved. Thankfully for this problem, when I distributed in, it gave me a whole number, but sometimes that's not going to happen. Sometimes we're going to be working with fractions, which is okay. At the end, we got an answer of negative 1, 3. So our lines cross at negative 1, 3. Let's try another problem with fractions to see how we would complete these. Now we have this problem, 6x minus 5y equals negative 9. and negative 7x plus 5y equals 13. And we're trying to find where they intersect. We're going to use substitution. I'm going to check to see if when I get my variable alone, if I can somehow get that constant that's attached to it to not be a fraction. So what I do is look at my constant on the right-hand side and to try to mentally divide it by each of my coefficients, just so I don't have to work with double fractions. Can we? Yes, but why not make our lives easier if we're able to? So negative 9 divided by 6 is a fraction. Negative 9 divided by negative 5 is a fraction. 13 divided by negative 7 is a fraction, and 13 divided by 5 is a fraction. So we can't avoid the fractions for our constants, which is okay. So now we're going to isolate one of the variables. We're going to get one of them by themselves. And we can choose any of these. No matter which one you choose, as long as you do the steps correctly, you'll still get the same answer. For some reason, the 6x is calling out to me, so I'm going to get the x by itself. So my first step is to add the 5y to the other side, so I get 6x equals 5y minus 9. Then I have to divide everything by 6, though, because I need the x by itself to be able to plug in. So I divide by 6, and I get x equals 5y over 6. And I can simplify this, divide both by 3, and I get negative 3 halves. It will make our lives easier to divide and simplify, so we're not working with as big of fractions. Now, I simplified and configured the first equation, so I'm not going to plug it into there. That wouldn't make sense. I'm going to substitute it into the second one for its x. So instead of x, I'm putting this. So I'm going to have negative 7 times 5y minus 6 minus 3 halves plus 5y equals 13. Now we have just the y terms like we wanted. So I'm going to multiply. I get negative 35 over 6y. This becomes plus 21 halves plus 5y equals 13. I'm going to combine my y terms. When I'm combining them, I like to get them in the same fraction, like the denominator, so I'm able to easily combine them. So 5 in 6 gives me 36. I take my 5, which is my numerator, it's 5 over 1, and multiply it by 6 to have that proper fraction. So I get 30 over 6, and I'm going to add these together, the negative 35 over 6 and the 30 over 6, which gives me negative 5 over 6y, plus 21 over 2 equals 13. Now I have to subtract 21 over 2, which this is the same thing as 26 over 2. So when I subtract this over, I get negative 5/6 y equals 5 over 2. Now, to be able to get the y by itself, I have to divide by negative 5/6, which is the same thing as multiplying by the reciprocal. So I'm going to multiply by 6/5, negative 6/5, multiply by negative 6/5, and my 5's cancel out. So I'm left with negative 6 divided by 2, which is negative 3. So my y is going to be negative 3. Just like before, once I get my y, I have to plug it in. I plug it into one of the original equations. I'm going to choose the first one. Once again, I don't know why that equation's just calling me. So I'm going to do 6x minus 5 times the negative 3, which is my y, equals negative 9. So 6x plus 15 equals negative 9. So 6x equals negative 24. So my x is negative 4. Once I get my two x and y, my two variables, I can plug it in to make sure it works. I get 28 plus negative 15 does give me my 13. I get negative 24 plus this would become positive 15, gives me negative 9. So my answer does work. I have to put it as an ordered pair though. So my final answer is negative 4, negative 3. So this does seem like a lot of work, but it's very beneficial. Some of my students love to do it this way where we're getting the x or the y term alone. Some of us look at this and say, I could have done elimination. Well, why not challenge yourselves and try to do the steps like this? Let's look at one more problem to make sure we're fully understanding this concept. For our last problem, I have negative 10x plus 10y equals negative 30, and then I have negative 6x plus 5y equals negative 15, and we're trying to see where these two intersect. I'm going to solve for my y. I like it when I divide by 5, I'm going to get an integer value. I love that, so I'm going to solve for that. So that means I have to add the 6x over. So I get 5y equals 6x minus 15, and divide everything by 5. And I get y equals 6/5 x minus 3. Now, I just solved for my second y in the second equation, so I'm going to have to plug it into the first one. So I have negative 12x plus 10 times 6/5 x minus 3 equals negative 30. So negative 12x. 10 times 6 is 60, divided by 5 gives me 12. So plus 12x minus 30 equals negative 30. Negative 12x plus 12x cancel each other out. It becomes 0. Don't write 0x. That's going to mess you up. So I'm left with negative 30 equals negative 30. And I like to think, is negative 30 always going to equal negative 30? Yes. So my final answer becomes infinite solution. So that means any point you plug in is going to give me the correct answer. If I were to graph these two, they would be the same line. So I hope this was helpful to be completing these challenging substitution problems dealing with fractions.